So if you remember that logarithms are exponents, it'll make the properties make more sense to you. Okay? So we have 3 main properties, but remember with exponents we had 7, right?
Yeah.
Right, Matthew? The first one is the product property. Product property. No, it's the same. I mean,
it's the ones that we took on the video.
It's the video you watched, yeah. So if you don't need to write them, that's fine. But I do just want to make sure, since I wasn't here to answer questions. Yeah, if you've already written them, if you just want to follow along, I don't know how close it'll be. I mean, that's whatever I taught it last semester, but it'll probably be fairly close. 11 years in, my notes are pretty close to each other, I think. All right, don't what? All right, product property. When you are multiplying with the same base, the base is B. Guys, if y'all could quit talking. Yeah. It's not going to be, you're just going to finish everything you haven't done.
Yeah.
All right.
Guys.
All right. So when you are multiplying, which is what I'm doing here, okay, with the same base, if I'm thinking in terms of exponents, what do you do with the exponents? Add them, right? So because logs are exponents, I use that same thought process, Matthew and Ben, and I split this up with addition. Now, if you noticed, the left side is kind of a smaller version of the right side. Okay, for that reason, if we go from left to right, we call that expanding. So I'm going to do an arrow that way. So if we take it from a small version and we make it a little bit bigger, we stretch it out, that's called expanding the expression. Okay?
And you said the other one was easier. I remember that.
Condensing. But if we take the bigger one and we go from left to right, we call that condensing. Okay? Kind of a compact version. Think like Campbell's chicken noodle soup, you got to add water to it, right? Because it's condensed soup.
Yeah,
packed up. Did I say that in another video too? Okay. Together. The next one's quotient property. Quotient. Same thing. If I am dividing, same base, but I'm dividing. Tell me what I do. Subtract. So I'm going to do the same thing here. I'm going to keep the base the same, and that's the key here, just like with exponents, is the bases need to be the same. Of n. Left to right would be what? Expand. How about right to left? Condense.
And when you say the base is the same, you mean like the base of 10? Like the base of
the B, whatever, yeah,
oh,
if it's a,
like
whatever that base is, yeah. You couldn't condense them into one
if it
unless,
was like log 2 and log 3.
Exactly, exactly.
I understand this.
Good.
I get it now.
This is pretty not.
Sorry. Last property is the power property. So if you think to exponents, if you are raising, if a log is an exponent, and you raise an exponent to another exponent, what does that mean you do? Well, y'all are telling me the answer because you saw this yesterday. But you multiply, right? So that's why this exponent comes around front and multiplies to the whole thing. Okay? Again, expand.
Wait, so whenever you're writing the answer, you take the exponent and then multiply it by log and then the number.
And so you just write it in front. Yeah.
Okay.
All right, we're going to practice with a few.
Wait, is there a division one?
Those are, it's only 3.
Yeah.
There's only 3.
Wait, and you don't
So you
have
can't
to
divide
use
logarithms?
You can, but I'll show you.
anything else in this
Make fun of
problem.
her.
It's just done.
Let me show you some examples. Remember, guys, remember with the properties of exponents, it was just a property, but then we combined everything together.
Yeah.
Same thing with these. All right, so let me give you an example because there's several other things I need to cover in this lesson with you. Let's do I really don't want to do the same ones y'all did yesterday. Let's expand this one. Some of these may look familiar to you, but that's okay. Now you have to understand as you look at this. This exponent is only hooked to the x, this exponent is only hooked to the z. Okay?
Whenever we're doing this, do we have to switch them? Like, other one?
What you mean? Change forms?
No, whenever you change the x and y for y.
No.
Okay.
These aren't inverses.
Yeah, right.
All right, so tell me what property you see that you could do.
Wait, I'm sorry, product.
Product, right? These are all being multiplied. So when they're being multiplied, I need to split them up with what? As somebody said, adding. So I get log, this is what y'all said was easy now, and some of you are looking at me like I'm doing something crazy. Plus log, remember that base has got to stay the same. So 7. Do you see any other property that I might could do?
Yes, power.
Power.
Log.
These come around to the front, only to the front of the log of which they're hooked. So now I have log base 7 of 5 plus 3, 7 of x plus log base 7 of y. These are ones that expanding, it's going to look like a really, really long problem that took you forever, but it really didn't because all we did was stretch it out from what it originally was.
What?
Yes. Oh, y'all always say I give you something different. Let's do one more before we're done with this. What if I needed to expand that?
Change the form? No.
Change it to a what? A power. That's exactly right. Change the
Yeah.
form. I think that's what you were trying to say, Anna. So I do log base 3 of 2x. What's the exponent become?
2.
1/2. Close.
How does it become 1/2?
Is this square root?
Because they're radicals.
Yeah. All right, so now, shh. Now what can I do?
Put the 1/2 in front.
The 1/2 needs to go in front. I'm not going to split this up first because this is 1/2 is applying to both of these. So I got 1/2. Now what?
You can split it.
Now I can split them up. And you're right, I need to carry the parentheses because this 1/2 still needs to go to both of them. Just like it went to both of them here, it needs to go to both of the logs. So I get log base 3 of 2 plus log base 3 of x. And I'm done. Make sense?
Mm-hmm.
All right, let's condense one then, see what happens. Condensing is a little bit different in that you need to move left to right as you condense. Let's start with an easy one. Base See anything you can do right off the bat? What?
You got your scissors back. Causing too much destruction.
Can move the numbers that are in the front.
Exactly. Those numbers that are in front can come around and become exponents. So I get log base 4, 2 to the 5th,
Yep.
x to the 7th, y to the 4th. What now?
The log 425. Can you do something like that?
You could make that if you want to change that to, what is that, 32? 2, 4, 8, 16,
Yeah.
32. You can, but what else can you do? What does this imply? Yep, multiply. I'm going to do 2 at a time. If you did them all at once, that's fine. When you start throwing subtraction signs in there is whenever it starts getting a little bit trickier.
Wait, you have to condense even more?
32x.
Because these are all the same base, you're going to continue to condense until you just have one log
How did you
expression.
get 32x?
2 to the 5th.
Oh, I see.
I'm going to multiply one more time because of this addition sign. So you get 32x to the 7th, y to the 4th. Pretty easy? I know y'all saw this yesterday, so I'm not going to focus quite as much on it, but I do want to touch on everything. You had some in your homework that several of you said were a little hard. That looked, and I'm going to use this example they have in the book. Look something like this. They give you some approximation values.
Oh, those are really easy.
Log base 4 of 7 is approximately 1.404. And then they ask you something like evaluate log base 4 of 3/4 without a calculator, just using what you're given.
You just plug in, don't you?
You do. So what you have to do is you have to expand it first, and when you expand, you can only use the numbers given.
So log.
Oh, I meant to write. I'm sorry. That should be 3/7. So in this case, it's already written as with the 3 and the 7, so I can just expand it out.
Log 3 minus log 7.
Exactly. And now I just sub in the values, right? This is log 3. Was this on the video yesterday too? Okay. So then I get this
What day is that,
Monday,
Shay? Yeah.
which would be negative 0.612. Is everybody good on these kind of, what if you had to come up with the numbers though? Like what if it was log base 4 of 21?
Plug it in.
3 times 7. 3 times 7 exactly. So it would be, I would need to change this to log base 4 of 3 times 7, and I do that so that I'm able to split it up. Do you see? Because all I'm given is a 3 and a 7, so I have to find some way to rework that and redo it to force it to be 3s and 7s so that then I can expand it and use what I'm given.
Missy, why are there so many different ways to do different problems?
It's the same thing. This is just using exact number values instead of variables.
There's like a million different ways to do something like this.
It's intuitive, Ben. So then, of course, I could sub these values in. 0.792 plus 1.404, and whatever that would come out to be. All right.
all called the same thing,
Last thing I want to show you.
like all these different ones.
This is all expanding and condensing, yes. Last thing I want to show you is change a base. Several of you asked, how do we put it in our calculator? Did y'all catch this yesterday?
Yeah.
Okay. So whatever, remember your calculator automatically does a base of 10. Whatever the base is though, if I wanted to say, and we'll do one that I know you know, base 2 of 32. That should give me what? Intuitively, I know that that gives me 5 exactly. So on your calculator though, whenever you put it in, it doesn't have a base of 2. So what we do is we do the log of this number, so of 32, divided by the log of the little number here, which is 2, on our calculator. So we're changing it to a base of 10. This can be any base as long as it's the same base on the top and the bottom. So let's put that in and just make sure we all come back to the same thing. Yes, you may. Let's do log of 32 divided by log of 2. And then you get your 5. Does that make sense to everybody? Okay, again, I kind of went fast through all these because I know you watched the video of the lesson yesterday.